Gravity does not gravitate at light speed as relativity asserts, nor do gravity wells exist in a flat space where our own solar system planets orbit almost in a straight line. If gravity acted strictly at light speed only, then regions of the universe receding faster than light would become gravitationally disconnected. Yet galaxies still form large-scale structures and maintain coherent gravitational behavior locally. Is the speed of light faster on Earth than in vacuum? Actually, the speed of light is slower on Earth than in a perfect vacuum. While the fundamental constant c, the speed of light in a vacuum, is approximately 299,192,458 ms, light slows down whenever it travels through a medium like air, water, or glass. Why it slows down? Refractive index. Every material has a refractive index. For Earth's atmosphere, this index is roughly 1003. This means light travels about 0.03% slower in our air than it does in the vacuum of space. Interaction with matter. As light photons travel through Earth's atmosphere, they interact with the electromagnetic fields of atoms and molecules. This interaction creates a slight delay in the transmission of the wave, effectively lowering the overall velocity through the medium. Density factors. The shifting weight of the atmosphere, the density of the air, determines how much the light is slowed. At sea level, where the air is thickest, light is at its slowest. As you move higher toward the vacuum of the grid, it speeds back up toward its maximum constant. The kinetic grid perspective. In your kinetic grid model, this can be viewed as grid resistance. In a vacuum, the 3D grid is at its most uniform tension, allowing light to travel at its peak velocity, c. On Earth, the planetary mass creates a warp or a high-pressure zone. This increased pressure and the presence of atmospheric matter act as drag on the grid, preventing light from reaching its true top speed. This confirms that the localized warp and atmospheric weight of a planet actually act as a buffer, slightly reining in the universal speed of light compared to the open expanse of the vacuum.
In space, matter becomes weightless. In a weightless vacuum, objects do not refract, nor does their mass create drag, where planetary gravity asserts a pull or drag on moving masses. Therefore, a ship in the vacuum of space, becoming massless, yet having the ability to travel at light speed, will travel twice as fast, asserting 2c velocity. The balance, where light is a speed relative to its own refraction or mass moving in a gravity field, the dragging must be subtracted to the velocity of the object moving at light speed. In SI ACE, light does not change because it's the physical speed of the photon and can't change. But referring to a ship's speed, light is not universal with the speed limit relativity asserts on it. Matter becomes weightless, meaning no slow dragging, no interior. The gravity of space is not the same as gravity on Earth. In Einstein's theory, they are the same, which causes arguments. No, a ship in space will travel twice light speed.
Hello world! Today we're going to talk about the geodesic curvature. In this version, the geodesic curvature that describes gravity, illustrated in a new formula. Darkness is filled with node particles. Space is not empty as some explain it to be. I understand this idea I have developed as the filler for freefall. A mesh of these particles directed under the planet's density field, not as a wave, but particle behavior. Even in the darkness of zero vacuum space, these particles assume their responsibility.
After all, we all come from a bunch of monkeys.